One week to grade 8 athletes. Please proceed to the gym entering from the lower level. Thank you.
Okay. So today we are looking at limiting and excess reactants, because the questions that we've done so far just assume that, everything reacts perfectly with one another. Like if you have a 1-to-2 ratio in the question, I'll give you one of these and I'll give you two of those, okay? But often you'll have more of one thing than you need and not enough of the other to use everything up. And so that's what we are looking at today. So we are considering the bread and cheese. This is a really boring sandwich, okay? It is 2 slices of bread and 1 slice of cheese. Now, I had to make the sandwich so that the cheese was like not in between the bread, otherwise you could not see the cheese. So it's a really stupid looking sandwich. You can imagine though that the bread would go on top, all right? So here is our balanced reaction. 2 slices of bread plus 1 slice of cheese gives us 1 sandwich. Now, if we had 3 slices of cheese and unlimited bread, all the bread in the world, how many sandwiches could we make? 3. That should be pretty straightforward, yes? Now, if we were given 4 slices of bread and an unlimited supply of cheese, under those conditions, how many sandwiches could we make? 2. Now, if I gave you 3 slices of cheese and 4 slices of bread, which substance limits the amount of sandwiches we can make? The bread, yes? And so the bread, you can see here we have 2 sandwiches and we have leftover cheese. So the bread gets all used up and it is called the limiting reactant. The bread limits the amount of sandwiches that can be made. That is why it is called the limiting reactant. So it limits the amount of product. Now, I just wanted to point out to you as well that sometimes instead of the word reactant, you'll hear the word reagent. It means the same thing. Okay? Now, there is excess cheese left over at the end of the reaction, so that's why we call the cheese the excess reactant. Okay, so whichever one limits the amount of product is the limiting reactant, whichever one has some left over at the end is the excess reactant. All right, consider this. We have the little square with a triangular hole, and we have a triangle, and we can put them together like that. Draw what will be present after the reaction takes place. So hopefully what you have is you have one of those and then 3 green triangles. Which of our things is the limiting reactant? The square. Actually, it's probably on the next page. Let's see. Which of the substances is the limiting reactant? The square. And which is the excess reactant? That would be our triangle. And I'm not quite sure where I was going with this. Oh yeah, because when we, like, it's not going to be this beautiful and simple when we do it in real life. So what you have to ask yourself is for each reactant, reactant A, or actually let's call it reactant X, okay? For reactant X, you could make 4 product. For reactant Y, you can make only 1 product. Whichever reactant makes the least product is the what do we call it? That is our limiting reactant. So one of the things you'll be called upon to do is to identify the limiting reactant. You could also be called upon to say, how much product can you make? How much product can we make? 1 product. So in doing, like in going reactant X, how much product can I get? Reactant Y, how much product can I get? You both identify the limiting reactant and you identify how much product can be made, okay? And we're going to stop writing limiting reactant and we're just going to write LR because it gets tiring, okay? So to figure out how much product will be produced, find the amount of product that can be produced by each reactant, X or Y. So you'll have reactant X, you'll have reactant Y. You'll convert each of those into product using, what would you use to convert them into product? What tool? Starts with an S. Stoichiometry. Okay, so you're going to use stoichiometry to take reactant X and find out how much product. Take reactant Y, use stoichiometry and find out how much product. And then whichever is the smaller amount of product, that's how much will be produced. This is also known as the theoretical yield. We will probably not be getting into percent yield because we only have like 3 classes left and tomorrow's a quiz. But if you want to do some enriched stuff, you could study the percent yield on your own. It's actually not that complicated, but we would use the term theoretical yield for that. All right, consider the following. 2H2 plus O2 gives 2H2O. When 6 moles of H2 react completely, how many moles of H2O can be formed? Do you think you can do that? Try it. did you get 2 moles of H2O? No, you shouldn't get 2 moles. You're like, why? Why would we get 2? I saw there were so many 2s, I got carried away. How much did we get? 6. I know, you're like, where did that come from? No, I'm sorry, my brain is like a little. All right, now try the next one. When 4 moles of O2 react completely, how many moles of H2O can be formed? And hopefully you got, what should I get? 8 moles of H2O. Now, why have I found my product 2 times? Why have I done this twice? Why have I found my product twice? Have a chit chat with your neighbors. Why have I found the product twice? Yeah, you have to say, okay, I've got reactant X here, right? And I've got reactant Y here. How much product can I make from reactant X? I can make 6. How much can I make from the amount of reactant Y that I have? I can make 8. Now, if we actually react 6 moles of H2 with 4 moles of O2, how many moles of H2O can be formed? Which of those 2 numbers? 6. So you look for the smaller number. Look for the smaller number. So the answer is 6 moles of H2O. Which reactant is limiting? So yeah, so once you find your smaller number, that's the amount of product, and whichever one produced that amount, that is going to be your limiting reactant. So that would be our H2. And that means which reactant is in excess? That is our O2. And this, I just brought this to your attention because sometimes people think, oh, I have less O2 because remember when I had O2, I have 4 moles. And when I have H2, I had 6 moles. And sometimes people are just like, oh, the smaller number must be the limiting reactant. Is that the case? No, because it depends on the coefficients in the reaction, which one will actually be limiting. No. How do you know which reactant is limiting? The amount of product produced by the limiting reactant should be smaller. The reactant that produces the smaller amount of product is limiting. Do you feel you could do the next one on your own? Or do you want me to walk you through it? Give it a try? Oh, actually, these are kind of funny questions. Okay, that's okay. Yeah, that's okay. Feel free to check your work. I'm slowly filling it in. By the way, there are other ways of finding the limiting reactant. I'm not going to teach them to you. We have 3 days left of actual classes. But if you come across them or you think you found a different method, just check with me about it. If you want to use it, that's fine. Okay? My form of method is a So how many moles of NH3 can be formed? 8. So basically, you don't actually have to show that in a separate step. You can just like box that one or put an arrow or a star or something like that. Which reactant is limiting? The H2 is limiting, and which reactant is in excess? The N2. Excellent. Okay. 7.2b. This is finding out how much of the reactant is left over at the end. Okay. So we're back to our bread and cheese, which is lovely. Okay, our nice little sandwich there. Now let's consider once again, we have 3 slices of cheese and 4 slices of bread. Earlier, we determined that the bread was the limiting reactant because you could only make 2 sandwiches from the bread, and the cheese was the excess reactant because you could make 3 sandwiches. Okay, so how much cheese do we have to start with? 3. Excellent. Okay. How much cheese gets used up? 2 slices of cheese because we're only making 2 sandwiches. Now, In order to find the amount of cheese that is used up, you can either say, I have 4 slices of bread, which will use 2 slices of cheese, or you can say, I'm making 2 sandwiches, which will use 2 slices of cheese. So either you can find this from the limiting reactant or from the smaller amount of product. So if you have 3 slices of cheese at the start and you use up 2 slices of cheese, such hard questions today. How much cheese is left over at the end? 1 slice of cheese. How do you figure out how much cheese gets used up? What's that? I would just say cheese at, yeah, start minus use. Cheese at the start minus the cheese. Oh, how much cheese get you? Oh, I'm so sorry. Yeah, that's the amount left over. How do you figure out how much cheese gets used up? Find it from the limiting reactant or from the smaller amount of product. And now this is the question that I was trying to answer last time. How do you figure out how much cheese is left over? Cheese left over equals cheese at the start minus the cheese used. And if you happen to have that sheet that I gave you last day, if you flip it over from the regular stoichiometry side to the other side, you will see this. So for a limiting reactant, step 0, write a balanced equation. Maybe you will be given a balanced equation. Does anyone not have one of these? Anyone need one? Okay. Write a balanced equation. Find the moles of each reactant. If you're not given moles, find the moles of product that could be produced from each reactant. So this would be finding reactant X goes to product, reactant Y goes to product. You will identify the limiting reactant, and then there we go, and then there's our excess reactant left over is the reactant at the start minus the reactant used. Where do we get the amount at the start? It will be given in the question. Yes? Where do we find the amount used? We either calculate it from the limiting reactant or from the smaller amount of product. Okay. Why am I clicking that one? I did not want to click that one. Sorry. Oh, yeah. There we go. Okay. So here we go. This is just an answer to the question. This is just what we came up with already. Let's get rid of teams. want that. Is good? Okay. So to find out how much excess reactant is used up, figure out how much reactant is required to react with the limiting reactant, or how much is required to produce the smaller amount of product. This particular worksheet doesn't focus on that method, but feel free to use it if you want to. All right, let's consider this little square and triangle problem again. Given 2 triangles and 3 squares, it is pretty obvious that the square is the who is limiting. Here's our limiting reactant, and this is our excess. Now you'll notice excess, if you want to abbreviate excess, you can abbreviate it as excess. Okay, so that's our excess reactant. So we have our limiting reactant and we have our excess reactant. How many squares are required to react with 2 triangles? 2. So what we have done is we've figured out this is how many squares actually end up reacting. All right, we started with 3 squares. We used up 2 squares. So how many squares are left over? 1. Okay. There's our before, there's our after, blah, 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 blah. Okay, let's do some examples here with real actual compounds. Earlier, we determined, so this was just on the worksheet that we previously did, we had 6 moles of the H2, and we had 4 moles of the O2, and we determined that H2 was the limiting reactant and O2 was the excess reactant. How many moles of O2 will be used up? When they react with the 6 moles of H2. Pretty straightforward, yeah. We've got 6 moles of H2. Remember, that's our limiting reactant. How much O2 is going to get used up? Cancel moles of H2, find moles of O2. And that is a 1-to-2 ratio. So how much O2 is going to get used up? 3 moles of O2 is used up. So now we had 4 moles of O2 at the start. And we have 3 moles of O2 used up. And so how many moles of O2 is left over? Yeah, 1. Is good? Okay. Obviously, the examples that we're going to be doing later are going to be more complicated than this, but that's okay. Okay, we determined, that should say 7.1a. Okay, 7.2a. 6. we determined that when 12 moles of H2 is reacted with 6 moles of N2, we found that H2 was the limiting reactant, and we found that N2 was the excess reactant. Using this information, find the amount of N2 that is in excess. When we say the amount of N2 that is in excess, we mean the amount that is left over. Do you want to try it? Okay. So I'm not actually going to get you to do these review questions today because I think we just did that. You can go and review those another time, but I'll get you to do some practice problems, which are on page 51. Okay, numbers 1 and 2. And then you could do, depending on how confident you are with all of the regular stoichiometry that we did to this point, there are questions on page 37, 38, 39, and 40. If you're feeling really good about everything, you could start with page 40 and work your way backwards, but if you're feeling kind of shaky, start with page 37 and work your way forwards. And maybe if you're like, okay, I'm doing okay on 37, you've done A and B, then maybe you move on to 38. Okay? So this is review for tomorrow's quiz. And if you're unsure what's going on, don't forget to refer to your regular stoichiometry chart for those ones, okay? You will not get that on the quiz, but if you get stuck, it can be like a little, brain jolt.